Hello guys, so welcome to our course, and this is the fifth week. This is our ninth lecture, and here is our first video. We're gonna cover a very important definitions. Uh, this is part of the Carnot map, okay, but it will be also our gate to our next method, which is the tabulation method. Okay, so what are these definitions that we must know? Basically, what's called prime implicants and essential prime implicants. And to give you an idea, this was basically formally should be discussed when we first discuss Carnot map. Okay, because knowing this will lead you to the systematic way we can say to solve or minimize any function using the Carnot map. Also we did already this by sense when we solved the Carnot map without knowing this prime implicant or essential prime implicant. We have this sense to find the minimized function out of the Carnot map. Okay, but the idea behind this sense that we got or we acquire by practicing Carnot maps is basically is prime implicants and essential prime implicants. So let's define them and take examples, and we see by doing that examples, we're gonna see that this is basically what we were doing just by sense. Okay, so basically, what is prime implicant? A prime implicant is when you guys have a Carnot map and you group, when you search for a one and group this one with all adjacent ones. Okay, the maximum group that this guy can belong to is basically the prime implicant. This is something that we're doing, without knowing what is this called. We just call it group. Okay, so the maximum group of one that any one in the Carnot map belong to is called basically prime implicant. Okay, you guys remember when we group 2 ones together or 4 ones together or 8 ones together? Okay, this is basically implicants. And if this was the maximum group that this one can belong to, this is called prime implicant. Okay, so what is the essential prime implicant? So basically, an essential prime implicant is a prime implicant, but it has some special characteristic in which, if you look at the ones in that prime implicant, which is now essential prime implicant, you will find that some of the ones there, maybe at least one of them, does only belong to that prime implicant or that group of ones, and does not belong to any other group of ones or any other implicants. If you go, guys, back to the examples that we solved in the homework, in the lectures, okay, you will find that sometimes you have ones that belong to many groups, and sometimes you have ones that just belong to one group. Okay, this group that has ones that belong to this group only is basically essential prime implicant. Okay, so let's take an example, and the example will make everything clear for us. And we're gonna take 6 examples because I know that topic is a little bit confusing. So we're gonna take a lot of examples, 6 of them, so we master it together. Okay, so for any example we're gonna take, we're gonna find the prime implicant, then the essential prime implicant, then we're gonna minimize the function. We're gonna choose some of these implicant, basically the essential plus some of the prime implicant, to form the most minimized form of the function. This is basically the systematic approach, okay, of solving Carnot map, the formal systematic approach. Although we already did that, but just by sense. Okay, so let's do that. So our system here, or our systematic approach, is as follows. We're gonna take anyone we find in the map. Okay, we're gonna search for the maximum number of ones or the maximum number of ones that this one can belong to, the maximum group, and this will be called the prime implicant. After finding all the prime implicant, we're gonna choose some of them as essential prime implicant based on the characteristics that I just told you about. After that, we're gonna construct, the function, the minimized function, basically. Okay, so here you start by any corner. You can choose this corner, this corner, this corner, this corner, and just take one cell by cell, we can say. So let's start by that corner. Okay, so that one here. Okay, can it be grouped in? Can this one be grouped in any group of ones? Yes. So basically, if you look here, these four corners, all of them has ones. And we said before, the corners, the Karnoff map is foldable. You know, the sides are foldable, top and bottom are also foldable. So basically, this is our first group or our first prime implicant. Now we will call it prime implicant. We will not call anymore the group of ones as group of ones. We know now it's a formal name and we will stick to it. Okay, good. Does this one belong to any other group of ones? No, it cannot. It does not belong to any other group of ones. Okay, this is a free cell. This is a free cell. Now the fourth cell in the first row here. Okay, let's check again. This guy is already contained in our first prime implicant. Does it contain? Does it belong to any other group? No. Good. Let's go to the second row. This is a free cell. Then this guy. This guy basically belong. It can be grouped with that guy here, just on the. But remember, these four are adjacent. So this is another group. If you can take four, don't take the two. Okay, we always look for the maximum group of ones that this guy can be contained in, or belong to. This is a prime implicant. So the second element in that row, the third element in that row, belong to this green. Then this is a free cell. Then let's go to the the third row. This one here basically can be grouped with two groups. So it can be grouped with these four ones. Okay, and also can be grouped with these four ones. So we get two other prime implicants now. Very nice. So far we have the gray prime implicant, we have the green prime implicant, we have the blue prime implicant, and we have red prime implicant. Okay, let's continue. This guy, the second element in the third row, belong to the blue, the green. It can't belong to any other group. The third element, again, blue, green. Fourth element, the blue and the red. Okay, no other grouping. Fourth row, the first element, belong to the gray, and the green the red, and doesn't belong to anything else, and the same for the last one here. So we have 5 implicants now. Okay, so let's now find out which one of them is essential prime implicant. Okay, so basically take each group, and whenever you find a group that has at least one, okay, that is not contained with any other prime implicant or with any other group, then this will be essential prime implicant. Okay, so let's start by the gray group. The gray group has 4 ones, this one, and the 2 at the bottom corner. The 2 at the bottom corner contained in the red prime implicant, but the 2 at the top corners, okay, are not contained with any other group except our gray group. So this is basically essential prime implicant. Good. So our first essential prime implicant is, remember here, this is WXYZ. So basically it is W is changing, Y is changing. So this is X bar Z, X bar Z, X bar Z bar. I'm sorry, yes, X bar Z bar. Okay. Now let's go to the green one. The green, look, these 2 ones in the third row is contained in the blue prime implicant, but the top 2 in the second row second row are only contained with this green prime implicant. So basically the green is essential prime implicant. Okay, and what is this green here? This guy is W is changing, X is not changing, and Y is changing. Z is not changing. So X is X bar Z. I'm sorry, X Z, not X bar. Yes. X Z. Yes, that's right. Now the blue is all the ones in the blue are contained with other prime implicants. For example, the first one is contained in the red. The second one is contained in the green. The third one green. The fourth one is one. So basically the green, the blue prime implicant is not essential. Okay, this is just the prime implicant. Just the prime implicant. Okay, and what is this one? It is W. Z is changing, X is not changing. WX and Y is changing. So it's WX. Good. Now the red one. All the ones again of the red one, the red prime implicant is contained with other groups or other prime implicants. So basically, the two ones on the left are contained in the gray and the blue. The two ones on the right are again contained in the gray and the blue. Okay, so it is just prime implicant, not essential. Remember, all of them are prime implicant, but some of them is essential, which is here the gray and the green. What is this guy? This guy is W. X is changing, Y is changing, W Z bar. W Z bar. Okay, so basically those are the essential prime implicant. Essential prime implicant. Here is how we write it, just EBI. And the second one are just prime implicant, not essential. Okay, now we want to find the minimum term or expression for our function f. So the rule saying that, look, all the ones should be contained in the f. I mean, you remember, guys, when we were doing just kernel map by sense, okay, once we group all the ones in the kernel map, we start minimizing, we start to find the expressions. So what we're gonna do now, okay, we're gonna take first the essential prime implicant. Why? Because if we exclude any of these essential prime implicant, okay, some of the ones will not be covered anymore. For example, if we exclude, let's draw this here. Yeah. If we exclude the green prime implicant, which is essential prime implicant now, these two ones will not be covered. Okay. If we exclude the gray essential prime implicant, these two ones will not be covered. But how about if we just remove the blue one? So if we remove the blue one, remember, all its ones are contained with other groups. So we can safely remove the blue, essential prime implicant without any problem. Okay? But at that time, don't exclude the red. Can we exclude the red? Yes, you can exclude the red. Why? Again, because all its ones are contained with other groups. Okay? But at that time, if you exclude the red, don't exclude now the blue. And I'm gonna show you now. Okay, so let's exclude the blue. Okay, so we're gonna redraw here the implicants again, except the blue one. So we have this guy, we have this guy, we have this guy, and we have this guy. Okay. Then we have the green. And look, guys. So look at these two ones. These two ones, this one and this one. They need to be covered. So they have two ways to be covered, either by the blue or by the red. That's why we can do any of them. So if we, for example, let's do first by the red. So I'm gonna make a big. So in that case, if minimum, I mean the minimum expression for f, the minimized f, it will be equal to basically the two essential prime implicant, the green and the gray. The green is x bar, z bar, and I will always stick to the colors so you guys can have this sense. X z, then the red here, which is w z bar. Can we do it another way? Yes, you can do it another way. If you take the blue prime implicant and exclude the red, then f will be x bar z bar plus xz plus now wx. So this is right and this is also right. Both are equivalent. So let's write both again, just f minimum. Another solution we can say x bar z bar plus xz plus wx. Both expressions are equivalent. Both are optimized. Both are minimized. Okay, you can go with any of them. Okay, that's basically this is basically what we were doing. Okay, but again, we were doing it by sense because it's a visual strength, and usually our maps is small, so we didn't need much of that formulation, we can say. Let's take another example. So again, find the prime implicants, same question. Find prime implicants, essential prime implicants, and finally minimize the function. So again, we start by the gray. Okay, and we take here one of the corners here. This guy belongs to that group. Again, the four corners are connected. So this is our first prime implicant. Then and it doesn't belong to any other implicant, and that give us a clue that this gray prime implicant is basically essential. Then this one here, this one belongs to. It can be done in two ways basically. So basically, it belongs to that prime implicant here. Remember, it's foldable. And also belong to that prime implicant here. And we have an idea now that the green prime implicant is just primary. It's not essential because the green prime implicant, all its ones are contained with other groups. But still, it's early to judge about the blue one. Okay. How about this one? This one, the last one in the first row. It contains in the green and it contains also in the gray, and doesn't belong to any other group. Good. So let's go to the second row. This one here, okay, can be grouped only with its adjacent one, which is that one here. Doesn't have any other adjacency. Okay. Good. And you look, guys, this again, this will give you a clue that this red prime implicant is also essential, because this one here, that guy doesn't belong to any other group in the Carnot map. Let's continue. Let's take black now. So this one, the third element in the second row, it belongs to the red, and also belonging to the blue and doesn't belong to any other, group. Okay. Then we go to the third row, the third element. The third element now, oh, that guy, is contained in the blue, but it can be contained with that group as well. These four ones together. This is also, a prime implicant. And now we can say that the blue prime implicant is not essential because all its ones are basically contained with other groups. Okay. Okay, good. Now let's go to the fourth element in the third row. This guy is contained in the black group or the black prime implicant. Okay, and it doesn't, it doesn't, belong to any other group. Okay, let's now go to the fourth row. Let's take any color, for example, this guy. So this one here just belong to the gray. Okay, and also can, just belong to the gray. Doesn't contain to it doesn't, adjacent to any other ones. Okay. The third element, the green. Oh, that one is belonging to anything, to many of them. It belongs to the green, it belongs to the black, it belongs to the blue. Okay. And that means you can remove, many implicants here, prime implicants here, and you will not, affect the final solution. You will minimize it better. And finally, the fourth one is also exhausted. It belongs to three groups again: the green, the gray, and the black. Okay, so it looks like these are all our implicants now. Now we want to, so let's write them first. Then we're gonna let's look for the essential ones first. So let's start by the gray prime implicant. So these two ones in the first column, this one and this one, only belong to one group, which is the gray group. So the gray is essential prime implicant. So what is this essential prime implicant? It's basically what W is changing. X is not changing, so X bar. Then Y is changing, but Z bar is not changing. So we have now essential prime implicant now. It's essential prime implicants. X bar, Z bar. What else? The green. So does the green is essential or just a prime? Let's check. So all its ones are contained with other groups. So, the first two ones belong to the green, to the gray and the blue. And the last two ones is also, the last two ones, the ones on the bottom row here belong to the black, gray, and blue. Okay. So just a prime implicant, not essential. So the green is X bar again. And after X bar, we have also Y is not changing. So X bar Y. Others are changing like Z and also W. Okay. Now the blue, as you see, guys, all its elements are belonging to other groups or other prime implicants. So it's not it's not essential prime implicant. So that guy is W is changing, X is changing, it's Y, Z. The red is essential. Why? Because this one here does not belong to any other group. So this will be W bar X, Y is changing, Z. W bar X, Z. Okay. Now the black is essential because this one here does not belong to any other group. Okay. So what is the black group? It is W, W is not changing. Then after the W, we have Y, because X is changing. So WY. And again, Z is changing as well. So basically, we have three essential prime implicant, and we have just two, normal prime implicant. Or we have five prime implicant. Three of them is essential. We can say so. Okay. Good. Now the minimized function. F minimum. So let's check here. Let's ask ourselves a question. Can we remove the blue one? And let's so what you do here is to first locate the essential, draw them, and after you draw them, if you find that they cover all the ones, then just the function will be the summation or of the essential prime implicant. That's it. So let's check that. And then the red, these two here. Then the black, which are these four. So we have three, and here we have liquidated the three. Now, so now we have one that is not covered, which is that guy. Okay, that guy can be covered by the green or the blue. Okay, so F minimum is equal to the essential prime implicant X bar Z bar plus W bar X Z plus WY, now plus YZ or plus X bar Y. Both are correct. Both are optimized. You can go with any of them. Okay, you can go with any of them. So F minimum can be, let's write it again here, either the first solution or the second solution, which is basically the first one, but just one term has changed, and both are just equal. Okay, so let's take another example. So again, same question. Let's find the prime implicant. So let's have our color map here, just not to hide many times. Okay, so start by the gray. So this guy here can be grouped with that one. And can be grouped with that one. Okay. No other groups, and this the maximum is just two in each group, or each prime implicant now. Then the third element in the row, or the second one in this row, this guy is already contained in the gray, and it also can be grouped with that one here, right? So we have here another group, and it can't be contained with any other group. That's it for this guy. Okay. Now let's go to the second row. This guy can be grouped with these four. And now we have a clue that the green prime implicant is not essential. Okay. And the gray also is not essential. And it's early to judge about the blue one. Okay. The second one in the second row is contained in the green and the red, and it cannot be contained with any other group. No other adjacent ones to it. Then the fourth row, this one here belongs to the red, and it also belongs to that group here. The complete row, third row. And now we can judge that the red prime implicant is essential prime implicant. Good. So let's go to the second one. Second one is in the red and also in the black prime implicant. The third one is contained in the black and also can be contained in another group, which is this group here. These four ones together. And now we can judge that the blue prime implicant is not essential. Okay. Good. How about the fourth one? The fourth one is already contained. Yeah. So it has two neighbors with one, and you know, and it's grouped by these two neighbors in two groups. Then the fourth row, this one is already has three neighbors. So it has, with two of them, it has a group, which is a cyan group here. And with one, which is on the top, because, you know, because of the folding, we also have a group. So now let's write the essential prime implicant. So essential prime implicant. Okay. Let's start by the gray. The gray is not essential prime implicant because we have two ones in the gray. Here is the gray again. We have two ones and both are contained with other groups, which is the green and the blue. So we have prime implicant and an essential prime implicant. So the green is not essential. It is just prime implicant, normal one. And this guy is W bar, X bar, Z. Okay. Now the green is not essential also. It is just a normal one. And it's W bar, then X is changing, Y, it's not changing, but it's Y bar, and Z. How about the blue? The blue is also non-essential or just a normal prime implicant. And it is X, W is changing, X bar is not changing, Y is not changing, and Z is not changing. Okay. Now, let's go to the red. The red is essential. Why is it essential? Basically because this one here is not contained with any other prime implicant or any other group. So that's why the red is essential prime implicant. So write this down. So W is changing, X is not changing, Y is not changing, but it's Y bar, and Z is changing. Okay. Now the black. The black is basically, you know, redundant. We can say it's, you know, all its elements are contained with other prime implicants. Okay. So we can write the black here, and the black is W, is not changing, X, WX. The cyan one. The cyan is prime. I'm sorry, essential prime implicant, because this one here is not contained with any other prime implicant or any other group. And the cyan group is W, X is changing, Z is changing, Y, WY. Okay. Now let's, you know, find the minimum F. So first draw the essential prime implicant and check if they cover all the ones. If they cover all the ones, then the function F is just equal to the summation of the essential prime implicants. Otherwise, you need some of the normal prime implicants. And the guy is the red guy. So the red guy is between these four. Very nice. Okay. So, you know, logically here, we need only the gray guy, this one of the prime. All other prime implicants are just, you know, redundant. Okay. So F here, and here we have just one minimized solution. Just one. So F minimum here is equal to X, Y bar plus WY plus the gray prime implicant, which is W bar X bar Z. Okay, that's basically this this function here. Any other situation, is not optimal at all. Okay, let's have another example. Okay, so as usual, we start by this guy here. So it has only one group, this group here. It doesn't belong to any other group. Okay, then this one here, it belongs to the gray, and this one. Okay, the second row, this one belongs to the gray group and these four together. So we have now gray prime implicant, green prime implicant, and blue prime implicant. And it's clear now that the gray prime implicant is essential. Okay, this one, the second one in that row, belongs to the blue and the gray and doesn't belong to anything else. Then the third one belongs to the blue, and we can also form another group here. That's very nice. So looks like now the blue is not essential, the blue prime implicant. Okay, the fourth one belongs to the blue and the red, and that's it. Okay, let's now go to the third row. This guy here belongs to the blue and also belong to that group. Okay, now go pick another color. The four, and doesn't belong to anything else. So the fourth one here belongs to the red, and yeah, just the red, no other, no other group. Okay, now the last row. This one is this one here belong to the green, and can be grouped also with that one here. Okay, then the last one here, which is M11, this one belonging to the black and the cyan and no other group. Okay, we just finished all of them. Now which is prime, which is essential prime implicant and which is just a normal prime implicant. Okay, so let's start by the gray one. The gray is essential because this one here doesn't belong to any other group. So this would be W bar, X is changing, Z is changing, Y bar. Now the green. The green is not essential because it has two ones, one of them with the cyan, one of them with the gray. Oh, I'm sorry. So the gray is essential. I'm sorry. The gray is essential. So let's write them. I just wrote it with the other one. Very sorry. Good. Okay, the green is not essential because it has two ones, one of them with the cyan, one of them with the gray. So the green is W is changing, X bar is not changing, Y bar is not changing, and Z is not changing. Good. The blue is basically not essential because all the ones are contained with other groups or other implicant or prime implicants. So the blue is W bar X. Very good. Now the red is essential because this one is not contained with any other group. The red is X, XY basically. Okay. Now the black is not essential because it has two ones, one with the red, one with the cyan. So the black is W, Y, Z. And finally, the cyan one is not essential as well. And it's equal to W bar, I'm sorry, W X bar Z. Okay. Now the minimized F minimum equal to, again, locate all the essential. So we have the red is essential. And the gray is also essential. And now look, we covered all the ones except two of them. So the best option is to take the cyan. Is to take that implicant here. That's the best option. Otherwise, you will be not, or you will have non-optimized solution. So our function is basically W bar Y bar plus XY plus WX bar Z. Okay, that's basically the solution of this example. Okay, so let's take now the example 4, and basically same stuff. We start by that guy here. So this one here belongs to, you know, this group. Okay. Then, and it doesn't belong to, it has no other adjacency. So the second one here belongs to the gray group also, and it can be grouped with that, you know, one in a green prime implicant. Okay. Now the third one can be, it's already grouped with its left one with the green, and it can be grouped with its below one or bottom one with another group here. Okay, and remember, we can't take 3 ones in a group. The number of ones in a group should be, you know, a multiple of 2. Okay, we finished with the third one. Let's go on to the second row. This one here belongs already to the green, and now it should belong to the red now, a new prime implicant, and it has no other, you know, adjacent, you know, ones. So let's go to the third row. This one here doesn't belong to anything, but now it can be grouped with one below, and then with another color can be also grouped with one on its right, and no other ones here. Now let's go to the fourth row. I'm gonna take another color, for example, this guy. So this one here is already contained in the gray, and it can be grouped with that one. Always take one, look at its adjacent, and remember the sides are foldable or also adjacent. Okay, that one here belongs to the gray and the black, and it has no other adjacent ones. Then the final one here only belongs to this pink color or prime implicant now, and yeah, it has no other adjacent ones. Okay, so now let's write what's essential, what's not essential. So essential prime implicant. The gray is essential because basically this one does not belong to any other group. So what is the gray group? It is W is changing. X is not changing, so it's X bar. Z is changing, so Y bar. Okay. Okay, the second group is the green. And the green basically is not essential at all because it has 2 ones and they are contained with other groups, the gray and the blue. So the green is W bar, X bar, Z, because Y is changing. The blue is also not essential because it has two ones and both are contained with other groups, the green and the red. But the blue is WY because Z is changing. WYZ, I'm sorry. Only X is changing. Here X is X, here X is X bar. Okay? The red. The red is not essential as well because it has two ones, one is the blue, one is the cyan. So let's write the red down here. So W is changing, X is not changing, Y is not changing, Z is not changing. Okay. The cyan or the black one first, no problem. The black is W, the black is not essential as well. So it's W, X is changing, Y is not, Z is not. The cyan is not essential. The cyan is W, X, Z. Y is changing. The gray is already taken. Now the pink one is essential, basically because that guy is not contained with any other group. Okay, so the pink is, let's write this, W, X bar, Y is changing, but Z is not. Z bar now. Yeah. Now the minimum F, we locate the essential prime implicant. And the gray as well. And now we have a lot of choices now. Okay. So, but looks like a decent choice is to take the cyan and the blue. So this is the blue. If we take the blue, we're gonna cover those. If we take the cyan, we're gonna cover the bottom two ones, which is just the rest here. Okay. Yes, that's basically what we should do. If we do the red, we will add two other prime implicants. So we will have three prime implicants instead of two. But with this solution, we have only two prime implicants. Beside, of course, this is a non-essential. So this is the only optimized way. So F minimum here, that's basically why I'm saying that, why it's not set when it comes to minimizing the function is not that easy, because basically it's a visual strength. You should visualize it. Here you should try once, for example, the red with the green, the red with the blue, the cyan with the blue, and you will find that the most optimized way is the cyan with the blue. If we include the red, we must have two other implicants, the black and the green. So we increased one term, one gate. Okay. If we take the green, okay, we will also have two other. We must include the red and the cyan. Okay, and so on. So F minimum is X bar Y bar plus the pink, W X bar Z bar, plus then the blue and the cyan, W X Z. Okay, that's basically this question here. So let's now take another, our last example finally. I'm gonna go with the same steps again, starting with the gray. Okay, this one here, basically this group, but it also belongs to other group, remember. So this one has, it's this adjacent here, the one on the right, with that guy, and the other can make a group, which is the gray group now. But remember, it has another adjacency, that guy. So it can also make another group. Which is nice. Okay, second one already in the gray, and so with all its adjacent, with that adjacent and also that adjacent, already in a group, so no other groups. So the third one here, it has two adjacency, so it is adjacent to that guy and that guy, and both of them already in a group. So now let's go to the second row. So this one here belongs to the gray. So with that adjacency here, it belongs to the gray. But with that adjacency and the other, it can also form another group, which is the blue group. Okay, the blue group. So we have now a third prime implicant. Let's continue. The second one with its top adjacent one, they form, and also the one on the right and the one on the left, they form two groups, the blue and the gray, and no other adjacency for it. The third one now, the third one with the one on the right and left, it's already in the blue group, but with the one on the bottom, it form another group. Okay. And no other group can be formed. So we go to the last one in the second row. This one with its top one, and remember with that one here form this gray group and the blue group. So it's also exhausted. No other group can be formed. Then we go to the third row. We have only one here. Okay, already exhausted with the grid group. Then we go to the final row. We have again 1. This guy can be only form another group with the one on the top, and that's it. Now we have a gray prime implicant, a green prime implicant, blue, red, and black, 5 of them. So essential prime implicant and normal prime implicant. So what is essentially? Let's start by the gray. The gray is essential. Why? Because this one here does not belong to any other group. So what is the W here? It is W bar. I'm sorry, what is the gray prime implicant here? It's W bar, Y bar. Because X is changing and Z is changing. Now the green. The green is not essential because all its ones are belonging to other groups like gray, like blue, and also black. Okay. The gray prime implicant is W bar, Z bar, because X is changing and Y is changing as well. Now the blue is also not essential because its ones are contained with green prime implicant, red prime implicant, and the gray. So sorry guys for this. Okay, we are back now. So we were talking about the blue. So its 4 ones are contained with other groups. So 2 of them in the gray and the blue. 1 of them, I'm sorry, the gray and the blue, the gray and the green. I'm sorry, and 1 of them in the red. Okay. So what is this blue one? It is W bar. W bar X. Yeah. Y is changing and Z is changing. Now the red. And the red, it's essential. Why? Because that one here does not belong to any other group. Oh. So what is this term here? It is W is changing, X is not changing, Y is not changing, and Z is not changing. Okay. Now finally the black. The black is essential because that one does not belong to any other group. Okay. So the black is essential. So the black is W is changing, X bar is not changing, y is not changing and z bar is not changing. Now let's find the minimum. So start by the essential prime implicants, then the red, then the gray. And look here, we only have one left. Okay, so if basically, if minimum equal to the 3 prime implicants, the gray, red, and the black, and now this one here can be contained with either the green or the blue. You can take whatever you want, because basically these two groups has 4 ones, so they will lead to the same, I mean the same number of literals in the same term. Okay, so because they have 4 ones, you know, if one of this group has 8 ones and the other has 4, you should choose the one with the 8, with higher number of ones. So you can do any of them. You can take the green or the blue. So I will highlight here the one of them, which is the blue, for example. So we can here plus W bar X, but again, you can make it with the green. And in that case, it will be W bar Z bar. Okay. So if minimum here has 2 solutions, not just one. W bar Y bar, then plus X Y Z, then plus X bar Y Z bar, then plus W bar X or W bar Z bar. You can go with any of them. Okay. I just show you one of them here, not to mix colors, Okay, guys, so this was basically, how to find the essential prime implicant, basically how to find prime implicant. Then some of these prime implicant will be essential. So then the second step is to find which prime implicant is essential, and based on that we can get the minimized or simplified version of any Boolean function using, of course, Karnaugh map. So basically we were doing that, but just by sense. Okay, and now here is the formal way of basically the Karnaugh map or Karnaugh map, And also you see now it is, Karnaugh map is really a visual way, It really needs a human to do it. It cannot be programmed easily, okay, or may not be able to, or we may not be able even to program it basically, okay. But the idea of prime implicant and essential prime implicant are basically the main or the milestone for the next method of minimization, which is called the tabulation method, which is basically a programming method. I mean, you can program it. We will do it basically on a paper and a pen, but you can take this concept, these steps of the tabulation method, and program it and make it as a program. Okay, then you can basically have very large number of inputs, something that we couldn't do with the Karnaugh map, and we don't need basically the visual strengths anymore. Okay, guys, so this was basically the end of Karnaugh map and the beginning basically of the tabulation method. So see you in the next video. Bye-bye.